Have you ever sat through planning meetings and had no idea why certain construction activities had to be completed in a certain sequence? Maybe a whole lot of complicated terms like mandatory and discretionary links, finish to start and start to start relationships were used and you had no idea what they meant. Or maybe you just find the whole topic of project scheduling overwhelming and confusing. Well, if you've answered yes to any of these questions, then this course is designed just for you. My name's Tim, and I'm an engineer with lots of experience on the design and construction of major infrastructure projects. I've been building short courses to teach the fundamental construction management skills to engineers and other construction management professionals. The courses are designed to teach the skills that you'll use on your job every day. And so far, we've had over 1,000 students enroll in our course. Each course is loaded with hours of content and practice activity to make sure you're equipped with the skills you need to excel at your job. This short video is an extract of our course on construction project scheduling, where we'll teach you everything you need to know about developing the network schedule. We'll talk about what the network schedule is, the different types of activity relationships, go through how to link activities, and finish with a detailed example. If you find this video interesting and useful, check out the link in the below description to our complete Udemy course on construction project scheduling. Hi, and welcome to section 2.2, linking activities. In the last section, developing the work breakdown structure, we defined all the work we need to do to complete our project. Now we want to go through and define the relationships between all the different activities. The WBS we created in the last section should have sufficient levels to go through and capture all the key activity relationships. This is the critical step for understanding how the work will actually be carried out and performed. Missing and not understanding these relationships will mean we don't understand how to deliver the project. This will lead to delays and ultimately the schedule falling behind as works aren't completed in the optimal sequence. So what is the network schedule? Basically, the network schedule is where we define and document the relationships between all the different project activities from the work breakdown structure. All the activities in the project will have a predecessor and a successor. The only exceptions will be the first activities. The first activity, which won't have a predecessor, and the last activity, which won't have a successor. Every other activity will need something completed before it so it can begin, and will need an activity, and they will allow another activity to commence when it's completed. This sequencing of activities is often referred to as the methodology, and it is a description of how the jobs will be delivered from the contract award through design, procurement, construction and commissioning, right up until the finished project is handed over to the client. The WBS told us all the work that has to be completed, but it doesn't tell us what order the tasks need to be completed in. That is the purpose of the network schedule. So, types of activity relationships. All activities will have a successor or a predecessor, except for the first and last activities. A number of different types of relationships can exist between activities. The most basic common relationship is a finish to start relationship. If we look at the diagram, that basically means that activity 2 can't begin until activity 1 is completed. Examples of this might be asphalting on a road project can't begin till the earthworks are complete, or construction can't begin until design has been completed. Another type of activity relationship is a start to finish relationship, which means that activity 2 can't begin until activity 1 has started. This is known as a must start together relationship. These are less common, but an example might be trenching across a road can't start until a road closure is started. We also have finish to finish relationships. This is where activity 2 can't finish until activity 1 is completed. For example, the fire sealing of rooms cannot be finished until the electrical work is complete for our design, or the design cannot be finished until all the stakeholder comments have been finished. Activities can have leads and lags built into the relationships. Leads and lags should refer to the period of time where work is not being completed. For example, if you're building a concrete foundation and need to wait 28 days for the concrete to cure before you can mount a steel structure, this is an example of a lag relationship. Or for example, if when submitting a design revision, the client has 14 days to make comments on the design before comment closeout can begin, this is another example of a lag. Relationships can also be mandatory or discretionary. Mandatory relationships refer to activities that must be sequenced a certain way to logically complete the works. For example, you can't mount a steel structure until the foundation has been completed, or you can't install electrical cabling until the cable containment has been installed. Discretionary relationships, on the other hand, are preferred but not compulsory. They are the nice-to-have relationships. Discretionary relationships are often put in place to reduce risk and save money, but can, if necessary, be removed. A classic example of a discretionary relationship would be between design and construction. Ideally, construction should not commence until the design is at issue for construction stage. But this is not a compulsory dependency, unless it is a contractual requirement. You can begin construction without an IFC design, but it adds risk, as design changes will lead to rework. Discretionary relationships are often removed when the project tries to accelerate the program. However, this would typically add risk and cost to the project. Now we understand what the network schedule is and the types of relationships between activities. Let's go through the process of actually linking all the different activities. First, take the logical groupings based on the levels in the work breakdown structure to understand the delivery methodology. Start at the work package level and work up. What is the process we're going to follow to complete the deliverable? Workshop this with the individual delivery teams and understand the sequencing to determine the methodology. Next, for each activity, link it to the successor and the predecessor based on the logical relationship to capture the methodology and all the leads and lags. You need to do this for the lower levels first and complete it for each logical grouping from the work breakdown structure. Review this first cut at the network schedule, ensuring all the meaningful relationships have been captured and the network schedule reflects the actual construction methodology. Review this with each delivery team and complete it for each subcategory. Finally, link each of the subcategories to get the overall network schedule. So, for example, on the road project, we discussed the structure category needs to be linked to utilities, which needs to be linked to earthworks. There will be some lower level relationships within this, and you may need to go lower to capture these. Once everything is linked and all the activity relationships are captured, you should have a complete network schedule that reflects how the project will actually be delivered. So let's go through an example of the street lighting from our road project. In the previous section, we defined the work breakdown structure down to the individual work packages. To begin with, we'll ignore the overall project schedule and look specifically at the delivery of the street lighting in Zone A. Let's start by understanding the construction methodology. To build the street lighting, we need to complete the civil works. This consists of the underground cable route involving pits and conduits and concrete foundations for the distribution boards and street lighting poles. We then need to install the street lighting poles, we need to install the 2 distribution boards, and finally, install all the lighting, cabling and luminaires known as the circuits. Before any of this begins, we need the earthworks within Zone A to be complete. There's not much point installing conduits until the shrubbery is removed and the ground level is at the correct heights. At this point, we can begin our street lighting civil works. Obviously, the foundations have to be in before we can stand the street lighting poles and install the distribution boards. However, the distribution boards and poles can be done at the same time. Hence, there is no relationship between these two activities. To install the circuits and cabling between the distribution boards and the street lighting, we need both the distribution boards and the street lighting and poles to be installed. Once this is complete, we can turn on our street lighting system and mark this off as complete. This is a very simple example, but we can see how we can then do this same level of detail for the earthworks, structures, utilities and roadworks to get an overall linked project schedule. Now we've gone through and understood the relationships between all the activities. To complete the network schedule, we need to know how long each activity will take. In the next section, we'll go through on how to estimate activity durations.